You are never going to take 94 derivatives on an exam. Please do not do that. What's going on? It's Marty from crambetter.com. If you want to follow along with the examples I'll be doing in this video, check out the video description to download the study guide. It's free to print or use on your tablet. We're looking at the most common application of Taylor series, which is finding higher derivatives. So if you've seen some question where you have to find like the 5,000th derivative of a function, obviously, you're not going to take a derivative 5,000 times. There's a pattern that you're going to want to come across. Now, this page right here is for your reference. There's a lot of good information on here after the video is done if you want to reference through like how this works and the procedure that I'm going through. I'm not going to read this off to you because honestly, it's just going to be a lot easier to jump in and do a problem and show you how I work through it, think through it. But that procedure is there just as a reference for you if you need it a bit later. I'm going to go on an extra page here just to have a little bit more room. And we're going to jump in and do it. So it says find the 94th derivative at 0 for f of x equals ln of 1 plus x squared over 3. Okay. Now I know a second ago I said that we're not going to actually take 94 derivatives, but this is kind of a weird case where, you actually need to take 94. I'm just messing around with you. Okay. I want to be clear. You are never going to take 94 derivatives on an exam. Please do not do that. Okay. So you're going to use the same sort of procedure in a second. Okay. But to be clear, please don't, if you're taking more than like 8 derivatives anytime on any question in an exam, then you're doing something wrong. So be really careful. All right. So anyway, here's how it works. The very first thing we're going to do is we're going to find the actual Taylor series for the thing that we're interested in. We're using Taylor series, right? So I'm going to start off with the most basic Taylor series. This is going to be for ln of 1 plus x. And I'm going to just plug in once I have that ln of 1 plus x series, okay? Now, this is one. It's one of those common ones that I highly recommend that you memorize. This is going to be sigma n equals 1 to infinity. And this is a weird one because it starts at n equals 1. So just be aware of that. And you have an alternator, negative 1 to the n minus 1. And this is going to be x to the n over n. No n factorial, just x to the n over n. Now, I have this table over here. You can reference it. There it is right there, just using that nice little reference. No big deal. We got it. Okay. So now with that said, we are going to then get the actual series that we're interested in. Okay. So the next step is once you have the overall, like the standard Maclaurin series that you want to use as, your reference here, you're going to find the actual one, which is going to be ln of 1 plus x squared over 3. So I'm just going to replace x with x squared over 3. So this becomes sigma n equals 1 to infinity, negative 1 to the n minus 1. That stays the same. But now I'm going to put x squared over 3 to the n, and that's all over n. And then we're going to clean this up a little bit just so we don't have like, fraction over fraction. So we're going to go sigma n equals 1 to infinity. This will be negative 1 to the n minus 1. Now I'm going to distribute this n to both the top and bottom of this. This becomes x to the 2n on top. Now, if I have a 3 to the n as my fraction, that's going to end up in the denominator. It's just like a little shortcut you can use so you don't have to do a bunch of extra algebra, and that n stays there in the denominator. So we're looking pretty good here, okay? So now, hey, before we go any further, I just wanted to mention to you that what you're watching right now is a topic review from crambetter.com. On our website, you'll find more stuff like this, as well as study guides and sets of practice exam questions for every topic in your course. So be sure to check it out. But for now, let's get back to it. Now, the next step, we just want to make sure that this thing actually exists, because sometimes you can have like a trick question where, the derivative is actually 0 because the power that you're looking for doesn't actually have a coefficient. So we're just going to make that quick little check off to the side here, okay? And we're going to set the exponent on our generic term, or excuse me, our specific term right here, x to the 2n, that's 2n. We're going to set that equal to the derivative that we're trying to find, which is 94, okay? So great, we just want to make sure that we actually have a derivative here. So I divide, and if I get a number, like a whole number, which when I do this, I get 47. 94 divided by 2 is 47. If I get a whole number, like no decimal in it, then that's good. That means that the derivative actually exists. It's not 0. I have an answer, okay? So now we're going to move on to the fourth step, and this is probably like the most key important step, okay? We're going to look at the generic term from the generic Taylor series. As a reminder, the nth derivative at 0, because we're looking for it at 0. So to be clear here, we're looking for 0, Maclaurin series here, over n factorial times x to the n. That is our generic nth term of the Taylor series. And if you look back at the procedure, we're kind of at that point now where we're looking at that generic power series term, the general term, okay? That's what that is, the generic general term. Now we want to set this equal to the other side, the actual specific term here that's going to get us the same power, okay? And actually, I don't want to set this equal because I want to start plugging stuff in. So to be clear here, what I'm doing now, this is just my reference. I'm going to plug in 94 for n in this case because I'm looking for the 94th derivative. So I'm going to go 94th derivative, f 94 in parentheses there, of 0. And if this is the 94th derivative, well, n is 94, so I have this divided by 94 factorial. times x to the 94, okay? Now that's fine. What I'm looking for on the other side now, so this is like the generic sort of term. What I need to make sure that this makes sense is I need to pull out the 94th power on x and whatever coefficient comes along with it. So that's what happens next here. So this is where it's tricky. You have to be really, really careful, like really careful to make sure that you're plugging in the right number. And it's actually kind of related to what we did up here. You have to ask yourself, what n do I need to plug in to this right here so I get the 94th power, okay? And the answer here is going to be 47. So we're going to plug in n equals 47 to this to get the 94th power on x, because the most important thing is that the powers on x on both sides of this equation match so that you can cancel and that you can get your actual derivative. So we're going to go negative 1 to the 47 minus 1 times x to the 2 times 47 all over 3 to the 47 times 47, okay? Again, that's the key, like very important part of this. Now, like I said a second ago, 2 times 47, that is 94, and that's a good thing. We want to make sure that those powers on x match. If they don't match, then you got to go back and try something. You have to find the correct n value, so don't proceed unless you have those powers as a match. I'm going to cancel the x from both sides. This is one of the rare cases when you can do that because, again, you're not really trying to solve for x, so it doesn't matter. And now we're going to just solve for that 94th derivative at 0 of f. So here we go. I'm going to multiply both sides of this by 94 factorial to get rid of that. So we get 94 factorial there. Those cancel. And I have the 94th derivative of f at 0 is going to equal 47 minus 1. That's 46. That's an even number. Negative 1 to an even number is just 1, so don't worry about that. And we got 94 factorial up top. And I'm going to write this as 47 times 3 to the 47. Not that it matters the order, I just like the way it looks a little bit better. To be clear, this is a factorial up top. I know that they got a little bit blended together, but there it is. So that's your final answer, okay? That's a really common question in terms of applications of Taylor series, so you want to make sure that you're really comfortable with that procedure and that you can do this question because it's very likely to appear on an exam, okay? So practice this, know that little subtlety with looking at the generic term versus the specific term from your specific Taylor series and making sure that those powers on the x match. Those powers match, then you're good to go. You just solve for the derivative term and you move on with your life. If you want to pass your classes the easy way, head to crambetter.com. We've got study guides, practice exam questions, and shorter, easier explanations for every topic in your class. So click the link in the video description and I'll see you there.